Hello everyone, today I am going to show you how to conduct independent samples t-test and Mann-Whitney U-test using SPSS, starting from testing or assessing normality to running the statistics or the independent samples t-test and the Mann-Whitney, as well as interpreting the findings or the output on SPSS. So these are the main headings that I'm going to tackle. So the first one is how to test normality by using the command of explore command or split file in case of two groups or more, and how to check assumptions and conduct parametric independent samples t-test. And in case there is a violation in assumptions or the type of data is ordinal, then we are going to see how to check assumptions and conduct non-parametric Mann-Whitney U-test, because non-parametric Mann-Whitney U-test also has some assumptions. So let's get started. Before starting, you should know the difference between dependent and independent variables, and you should know the levels of measurement that are in the acronym NOIR in French, which stands for nominal ordinal interval ratio, nominal or categorical like gender, male, female, ordinal like 5-point Likert scale ranging from strongly disagree to strongly agree, interval and ratio. They are classified in their continuous label or one variable in SPSS, so we're not going to distinguish between them. So you should be familiar with the p-value and the 0.05 alpha level, etc. So let's start how to test normality in SPSS graphically and numerically. So there are two methods. So numerically or graphically, which one to choose? We can choose them both. Why? Because statistical tests are not sensitive enough for small sample sizes and overtly sensitive in case of large sample sizes. Moreover, plots or graphs can be used for visual inspection, and this will help you visually see the distribution of the data, although it's not subjective. As you can see, in general, statistical tests are objective, whereas these graphical presentations lack objectivity. So two methods of assessing normality we have. If you have one group, use the explore command function on SPSS, and if you have two groups, for example male, female, you can use the split file and the explore command. So let's see the first method, that is the explore command for one group. For example, we are going to follow the following steps to test normality. First, you click on analyze or click analyze, then descriptive statistics, then explore. Let's see this using SPSS. So we have our variables entered on SPSS, then we can go to analyze, descriptive statistics, explore. Okay, as you can see, once we do this, we will have the explore dialog box in which we are going to transfer these variables, for example the course, which is a categorical variable, and time. So here time depends on course, so we're going to move and time to dependent list by dragging or just using this arrow, and dropping or just using this arrow, as you can see. Then once you have like this dependent list and factor list, click OK statistics, and we are going to have explore statistics, descriptives, and confidence interval for mean 95%, which is 0.05, and then click continue. We are going to have explore plots, and we uncheck stem and leaf. We can choose just histogram and select normality plots with tests and click continue. Next, you click continue and click OK, and you are going to have your results on the output. So there are two types of the columns in the output. We have the Kolmogorov-Smirnov test and the Shapiro-Wilk tests. So if in case of small size sample, we are going to use the Shapiro-Wilk test, especially if sample is less than 50 individuals. If the sig value of the Shapiro-Wilk test is greater than 0.05, the data is normal. However, if it is below 0.05, the data significantly deviates from a normal distribution, and at this stage we cannot conduct the parametric independent sample t-test, and we move to the non-parametric Mann-Whitney U-test. So another technique to test normality is on the output of SPSS by checking the skewness and kurtosis. So if you want to test the normality by seeing whether the data is skewed or kurtotic, you need the following steps. So you should have your calculator and calculate manually the z values or the z values of each sample by dividing the skewness and kurtosis of each sample, for example male and female, by standard error consecutively, and the result should be between plus or minus 1.96. So you can do this manually. This is just, it involves some work, but you can bear that. Next, we have checking normality using or visually by using the normal QQ plot or plots. So graphically normality distribution data through inspection of QQ plots can be done by observing the points that should be close to the diagonal line, as you are going to see. If the points are close to the diagonal line on this QQ plot, you can conclude that the data is normally distributed. So as you can see, the points should be close. If there are some points that are far, these are like outliers. You have to check whether the entry of data is this has been done correctly, or there are some mistakes in the entry of data. So once you finish, you can go and conduct your independent sample t-test if it is normally distributed. For the second technique, which is the split file command for two independent groups, we are going to follow the following steps on SPSS. For example, click on data tab and then split file, as you are going to see on SPSS. So we go to data and we go to split file. So once we split file, we are going to have this split file dialog box, in which we are going to move gender to these groups. As you can see, gender and educational level, these are two independent samples. And we want to see, for example, whether these have an influence on interest in politics. Okay, so we click OK. Once we finish, we click OK. And if we want to know interest in politics, like is normally distributed when grouped or categorized by gender and educational level. So as I told you, we have two independent sample or independent groups. So for example, the file now is split, and the output from any test will be organized into the groups you have selected once we click OK. So once we finish, after split file, we go to explore data. By the way, I already showed you by the command and explore. So you go to analyze descriptive statistics, explore. So as you can see, analyze descriptive statistics, explore. So step 1, we should do this, and step 2 is we are going to have an explore dialog box like this, and we're going to move variables, again the independent variables, to the factor list. But since they are split file, there is no need to move them here because we should be cautious. We just move the interest in politics into the dependent list. That's it. And we can check statistics, plots, option, etc. to choose what tests we want to see. So as you can see, and this is the warning. Why? Because we cannot simply transfer these two independent variables into the factor list box, because this will not achieve the desired result. It will first analyze interest in politics for normality with respect to gender, and then with respect to educational level. It does not analyze interest in politics for normality by grouping individuals into both gender, educational level at the same time. So this is the problem. I'm going to list references at the end of the presentation. So for statistics and explore statistics, we are going to again group this variable gender as or interest in politics as dependent list. and we are going to choose explore statistics, and we're going to click descriptives, and for the confidence interval for me it should be 95%. Then continue. So leave the options unchanged. We are going to leave these other options like outliers, percentiles, M estimators unchecked, and then continue. Then explore plots, continue. Okay, so we are going to in the explore plots we are going to, for example, to choose histogram better than stem and leaf, and normality plots with tests, and then continue to see normality visually and statistically. So how to interpret the normality output for split file? So we have again two tests. We have the Kolmogorov-Smirnov test and the Shapiro-Wilk test, depending on the sample size. So we are going to have this table in interest in politics, and we have statistic, difference, sig, statistic, diff, and sig. So we are going to rely on the values of the Shapiro-Wilk test, which is 0.5, which is greater than 0.05, and then we can make decision as to the null hypothesis, which states that there is no statistical or statistically significant difference in the distribution of the two variables. And if the p-value is less than 0.05, then we can reject the null hypothesis. If it is greater than 0.05, we fail to reject the null hypothesis, and we can state that the data is normally distributed because there is no statistically significant difference between the two groups or the two variables. So let's move to the QQ plots to check this visually. As you can see, the data is distributed this diagonal close to this diagonal line, and therefore we can conclude that the data is normally distributed. For assumptions for or of the independent t-test, so we have like 6 assumptions. I'm going to start with the first assumption of the independent samples t-test. It's called the independent samples t-test or the independent t-test. So assumption number 1, it states that your dependent variable should be measured on a continuous scale. So it should be a continuous scale, either interval or ratio. For example, like test scores, like temperature, degrees, or values, etc., weight, height, etc. So it's measured at the interval or ratio level. And examples of variables that meet this criteria include revision time, like in minutes or hours, intelligence measured in IQ score, and exam performance measured from 0 to 100, or weight measured in kilograms, and so forth. So this is assumption number 1. For example, just to remind you that if the data is ordinal, we can use the Mann-Whitney U-test without questioning this. Okay, and so the Mann-Whitney is a non-parametric test. Assumption number 2, your independent variable should consist of 2 categorical independent groups. So there should be 2 independent groups, like male, female, etc. Example independent variables that meet this criterion include gender. For example, 2 groups. We have the group of male and the group of female. Or employment, we have, for example, employed or unemployed. Smoker, we have smokers, non-smokers, etc. So there should be 2 groups. That's it. If you have 3 groups, you are going to do 1Y ANOVA, or analysis of variance. Assumption number 3, you should have independence of observations. That is each sample should have different individuals, that one individual should not participate in 2 samples. Otherwise, you are going to need the paired sample t-test. For example, if you conduct pre-test and post-test, because you have the same individuals, but their performance varies from the pre-test to the post-test. So here, there should be independence of observations. There must be different participants in each group, with no participant being in more than one group. This is more of study design issue than something you can test for, but it is an important assumption of the independent t-test. If your study fails this assumption, you will need to use another statistical instead of independent t-test, which is the paired samples t-test, as I told you. And some students keep asking questions whether the participants, the number of participants should be equal. Well, for this independent sample t-test, it should not be equal. It doesn't matter if we have group, or for example, gender, we have 12, and female, and for females we have 12, and male students, for example, we have 10. It doesn't matter, provided that it should not be greater or very strong difference, or how can I say that? There should not be a high margin. So anyway, assumption number 4, there should be no significant outliers. And as I told you, outliers, these are excessive values that do not fit the model. For example, outliers are simply single data points within your data that do not follow the usual pattern. For example, in a study of 100 students' IQ scores, where the mean score was 108, with only small variation between students, one student has a score of 156, which is very unusual, and may even put her in the top of the first one of IQ scores globally. The problem with outliers is that they can have negative effect on the independent t-test, reducing the validity of your results. Fortunately, when using SPSS statistics to run independent t-tests on your data, you can easily detect possible outliers, and you can clean them if you can. Otherwise, you have to check for mistakes in entering data, or use non-parametric tests. Assumption number 5, your dependent variable should be approximately normally distributed for each group of the independent variable. So here we talk about approximately normally distributed. So we're not talking about exactly normally distributed for each group of independent variable. We talk about the independent t-test only requiring approximately normal data, because it is quite robust to violations, or quite robust to violations of normality, meaning that this assumption can be little violated and still provide valid results. Because sometimes you may run the risk of having type 1 error, which is false positive. You accept a null hypothesis, although it should be rejected, or you should fail to reject it. So you can test for normality using the Shapiro-Wilk test of normality, which is easily tested for using SPSS statistics. Assumption number 6, we have there needs to be a homogeneity of variance. The term is like a Greek term consisting of homo, which means the same, and geneity, or which means the same nature of variance. Here we are talking about variances, we are talking about standard deviation, etc. You can test this assumption in SPSS statistics using Levin's test for homogeneity of variances. So when we conduct a t-test or independent sample t-test, you are going to have this test, and you are going to show you how we can interpret the results for it. So how to run independent samples t-test and interpret the results using SPSS. So the first one is analyze. Click analyze, compare means, independent samples t-test, as you are going to see. So analyze, compare means, and then independent samples t-test. We click on that. We are going to have a dialog box like this, independent samples t-test, and we are going to put the dependent variable in the independent, on the dependent or the test variable, and the grouping variable in this grouping variable. This is the independent list. And then click define groups. So we are going to have this option. You have 2 question marks. We're going to click define groups, and in the dialog box we put 1 for group 1 and 2 for group 2. Once we finish, we click continue, and then click continue, okay, and you are going to get the results. And how to interpret the output of the independent samples t-test and SPSS statistics. So we are going to have this table. So we are going to be interested, you see here the equal variance assumed and the equal variance is not assumed. So you can see, and we have sig two-tailed, so we are interested in the sig two-tailed values, because they should be less, or we should interpret this in the light of the p-value that is 0.05. So as you can see, the sig two-tailed, here we have 0.02 or 21, and this value is below the 0.05, and therefore we reject the null hypothesis, which states that there is no statistically significant difference between the two groups. And we can look at group statistics to see where the difference is exactly. So we have mean and the mean of the cholesterol and concentration, by using a diet or exercise. So here we have diet has a mean of 6.1, and for the exercise it has a mean of 5.7. So obviously they are different. And the diet has more cholesterol concentration than the exercise. That is, the more you do exercise, the less cholesterol concentration you have in your blood. So anyway, this is the interpretation of this descriptive statistics, or group statistics, sorry. Assumptions. Now we move to the assumptions of the Mann-Whitney U-test. So we have finished with the independent samples t-test. We are going to move to the assumptions of the Mann-Whitney U-test. Okay, so assumption number 1, your dependent variable should be measured at the ordinal or continuous level. For example, we have ordinal variables include Likert scale or items, 7-point scale from strongly agree through to strongly disagree. Amongst other ways of ranking categories, we have 5-point scale, explaining how much customer liked service, ranging from not very much to yes, a lot. Or examples of continuous variables include revision time measured in hours, intelligence measured using IQ score, and exam performance measured from 0 to 100, weight measured in kilogram, and so forth. Assumption number 2, your independent variable should consist of 2 categorical independent groups, like for example, of independent or examples of independent variables that meet this criterion include gender, like we have 2 groups, male or female, employment status, 2 groups, employed, unemployed, smokers, non-smokers. So it's the same assumption of the independent samples t-test. Then we have assumption number 3, you should have independence of observations. That is, there is no relationship between the observations in each group or between the groups themselves. For example, there must be different participants in each group, with no participant being in more than one group. And this is more of study design issue than something you can test for, but it's an important assumption of the Mann-Whitney U-test. And if your study fails this assumption, you will need to use another statistical test instead of the Mann-Whitney U-test, which is the Wilcoxon signed rank test. So if you have different, or if you have the same participants, like in paired samples t-test, the non-parametric alternative for the paired samples t-test is the Wilcoxon signed rank test. We can see this in another tutorial. For assumption number 4, the Mann-Whitney U-test can be used when your 2 variables are not normally distributed. So there is no assumption of normality here. However, in order to know how to interpret the results from one Mann-Whitney U-test, you have to determine whether your 2 distributions, that is the distribution of scores for both groups of the independent variable, for example, males and females, for the independent variable gender, have the same shape. To understand what this means, take a look at this diagram. So here the same shape. So this is an identical distributions to the extent that you cannot see the distribution of each category, males and females. And this is the same shape, different location. Okay. So here you have the same curve that you can see. So this assumption is in order to test or to use the Mann-Whitney U-test. When 2 distributions have different shape, you have to compare the means rank of your dependent variable rather than the medians, okay? So this is in case you have different shape. Next, we are going to see how to do this using SPSS. So we have analyze. You go to analyze non-parametric tests, and you go to legacy dialogues, and choose independent samples, and click on independent samples. Then you have 2 groups. We have the diet and the exercise group and the cholesterol group. we can move the cholesterol group to the test variable and the diet and exercise group to the grouping variable, that is the independent variable, and select Mann-Whitney U. And we have other choices like Kolmogorov-Smirnov, Z, and Wolfowitz-Renz. So once we do that, we can go to options or go OK. Either way, you are going to again define groups. We need to define groups before going even to options. So when we click define groups, again we are going to put group 1 as group 1, group 2 as group 2, and then click continue and options. We are going to choose descriptive or quartiles or both, and then continue, and then click OK. So we're going to have the output, and we have the cholesterol concentration in group 1, which is the diet group, and group 2, the exercise group. You see the number of the participants. We have 20, and we have mean rank, and we have sums of ranks. So the mean rank, as you can see, we have 25 and 16. So just visually it's different. So for test statistics, we are going to use this table, asymptote dot or point sig two-tailed. So we can take the p-value, which is here 0.01. This p-value is less than 0.05. If we have the p-value that is less than 0.05, or we reject the null hypothesis that states that there is no statistically significant difference between the groups, and this means that there is a statistically significant difference between the groups, and therefore we can conclude that there is statistically significant difference between the groups. So these are the references that you can consult and that I used in this tutorial, and if you have questions or remarks, you can post them below, and see you in another tutorial.